The paper investigates the physical and orbital properties of free-floating planets that are ejected from their planetary systems due to planet scattering, a common dynamical instability process in young planetary systems. Thousands of free-floating planets have been detected, for example, via microlensing surveys, but their formation mechanisms are still debated. Two main hypotheses exist. First, formation in isolation, like stars and brown dwarfs. Second, ejection from planetary systems, likely during the early, dynamically active phase. This study focuses on the second, ejection due to planet scattering in multi-planet systems. Numerical N-body simulations were run for systems with 3 to 6 giant planets, with varying masses and orbital architectures. They modeled gravitational interactions over long time scales, tracking which planets are ejected and under what conditions. A significant fraction, up to 40 to 70%, of planets in unstable multi-planet systems are ejected. Systems with more planets tend to eject more. Ejected planets are not random. Lower mass planets are more likely to be ejected than massive ones. Ejected planets tend to be the outer ones, though not exclusively. The velocity distribution of ejected planets is typically a few kilometers per second, allowing them to escape the system but remain gravitationally bound to the galaxy. Some free-floating planets may retain moons after ejection, especially if they were originally giant planets. Binary planet systems can, though rarely, survive ejection. The mass function of ejected FFPs is biased towards lower mass objects, not reflecting the initial mass distribution of planets. Many ejected planets may still be warm or young, making them potential targets for direct imaging in the infrared. There is a tail of very high-velocity ejections, possibly observable as hypervelocity planets. Planet scattering is likely a major source of free-floating planets, especially for lower-mass ones. The properties of the ejected planets, mass, velocity, original orbit, depend strongly on the architecture and dynamics of the original system. This process helps explain the diversity and population statistics of observed free-floating planets. Future surveys, for example with Roman Space Telescope, Euclid, or James Webb Space Telescope, may be able to constrain these models by detecting and characterizing more free-floating planets. Watch the Science Pop series, Zane's Diary, on the Stellar Attractor channel. There's enough sky for everyone.